Imagine you're out on your property, maybe miles from the nearest outlet, or maybe the power grid's just gone down.
Right.
You've got your tractor sitting right there, a really powerful engine just, oh, waiting. What if you could actually tap into that engine to make your own electricity?
Yeah, that's really the core idea behind these PTO generators.
And that's what we're diving into today. We want to understand why these clever devices exist, how they work, but, without getting totally lost in the technical weeds.
Exactly. Our goal is pretty straightforward. Give you a clear picture of PTO generators,
Wow.
why they're so useful, and the basics behind how they operate.
Okay.
And we'll be drawing on, technical docs, manuals, mostly about alternators and generator tech to get the key points across.
Okay, so let's get straight to it then. What is a PTO generator?
Fundamentally, it's an electrical generator, but it's specifically designed to be powered or driven by the power takeoff shaft, the PTO.
The PTO you find on tractors and some other heavy equipment.
Exactly. Tractors, agricultural machines, sometimes industrial ones too. Think of it like you're just borrowing the muscle from your tractor's engine
Right.
to spin the generator and, well, produce electricity.
It sounds like a really smart way to use what you already have. Is that the main reason they exist?
That's absolutely the core reason. It's about leveraging an existing power source, your tractor engine.
So you don't need a whole separate engine just for the generator.
Precisely, which can make it, a really cost-effective solution.
Yeah.
And efficient, too.
Especially if you're out in the middle of nowhere or maybe just need reliable backup power.
Perfect examples. Remote locations, grid outages, farm backup, that's where they really shine.
Now, making electricity. I know it's not just about spinning something fast. There's a connection, right, between the speed and the type of electricity.
Oh, definitely. The electricity we use, say in North America, has a standard frequency, 60 hertz.
Meaning it alternates 60 times a second.
Correct. And that frequency, it's directly tied to how fast the generator's rotor spins and how many magnetic poles are built into that rotor.
Okay, so speed plus internal design equals the right frequency.
Essentially, yes. To get that 60 hertz with a common four-pole rotor design, you actually need a pretty specific and quite high RPM.
High speed. Does that cause any issues?
Well, it generates significant centrifugal force. Engineers have to design those rotors very carefully so they don't fly apart under the stress.
Right, makes sense. So inside this generator, the real workhorse is the alternator. That's the bit turning mechanical power into electrical.
You're spot on. The alternator is absolutely the heart of a PTO generator.
How does it actually do that conversion?
It works on a basic principle of electromagnetism. It sounds complicated, but the idea is simple. A changing magnetic field moving past a wire makes electrons move in that wire.
Okay.
So you generate a magnetic field, you move it past coils of wire, and voila, you get electrical current.
And how does the alternator create that moving magnetic field and, use the wires?
Inside, you've got two main parts. There's the rotating part, the rotor. That's what creates the magnetic field, usually using electromagnets.
Okay, the rotor spins and makes the field.
And surrounding it is the stationary part, the stator. This holds the coils of wire. We call them armature windings.
Got it.
So the tractor's PTO spins the rotor, its magnetic field sweeps across those stator windings, and that induces the alternating current in the wires.
I often hear about three-phase power with generators. Is that common here?
Yes, many PTO generators are designed to produce three-phase AC power. It's very efficient for running larger motors and equipment.
How do they get three phases instead of just one?
They use multiple sets of those armature coils in the stator, typically 3 sets, arranged sort of 120 degrees apart from each other.
Ah, so the timing is slightly different for each set of coils.
Exactly. As the rotor's magnetic field sweeps past, it generates a current in each set. But because they're physically offset, the currents peak at slightly different times. Those are your 3 phases.
And how are those coils connected?
Often, they're connected in what's called a star configuration. This setup gives you specific voltage relationships between the phases and a neutral point.
Designing these must be quite a challenge, trying to get everything right. What are the engineers aiming for?
It's definitely a balancing act.
Yeah.
You've got several key goals. First, cost effectiveness, getting the most electrical output measured in kVA.
kVA, kilovolt amps, like the apparent power.
Exactly, the apparent power capacity. So maximizing kVA for the amount of materials used. Then there's operating efficiency. You want to convert as much tractor power into electricity as possible, not waste it as heat.
Makes sense. Anything else?
And crucially, designing for low reactances. This helps the generator handle changing loads smoothly, especially when starting big motors, which can draw a huge surge of current initially.
Yeah.
Good load acceptance, they call it.
Different places use different electricity standards, right? Voltage, frequency.
Yeah.
How do manufacturers handle that?
That's a huge consideration. Companies like Mech Alte, and it's pronounced Mech Alte.
Mecalte got it.
Yeah, right. They design their alternators to be flexible. They use different winding configurations inside the stator to match regional needs.
So one basic design might be adapted for, say, Europe versus North America.
Precisely. You might configure it for 400 volts at 50 hertz, common in Europe, or maybe 480 volts at 60 hertz for North America, among other standards.
Now, I read something interesting, that some three-phase alternators can actually be set up to provide single-phase power. How does that work?
Yes, that's possible with certain alternator designs, specifically those built with 12 connection points or leads.
12 leads, okay.
These can often be rewired internally into what's called a double delta configuration. This essentially rearranges the coil connections to deliver a powerful single-phase output.
Why would you want to do that?
It's really useful in applications like rural power supply, where you might primarily need single-phase for homes or specific equipment rather than running large three-phase machinery.
So you could get, like, 480 volts single-phase from it.
Exactly, potentially 400 volts at 50 hertz or 480 volts at 60 hertz, but in single-phase form, which is sometimes more practical.
Let's talk about that kVA rating again. You see it on every generator. What does it really tell us? And does it relate to how long the generator might last?
The kVA rating is fundamentally about the alternator's power handling capability, as we said, but what limits that capability is mainly heat.
Heat. Inside the windings.
Yes. The insulation materials used around the copper wires in the stator windings have temperature limits. The kVA rating is largely determined by how much heat those insulation systems can withstand over the long term, linked to the expected operational life.
So better insulation means a potentially higher kVA rating or longer life.
Or both. It's about managing the heat generated by the electrical current.
I've seen these insulation classes mentioned, like Class H or Class F. What do they signify?
Those letters represent standardized temperature ratings for the insulation materials themselves. Class H, for example, can withstand higher temperatures than Class F before it starts to degrade. So, a Class H system uses materials inherently more heat resistant. This gives the designer options for how hard they want to run the alternator.
So if an alternator could run hotter, because it has Class H insulation, but it's designed to run cooler in normal operation?
Yeah,
Does that help it last longer?
absolutely. That's a key point. If you operate an alternator well below the maximum temperature limit of its insulation class, you're putting much less thermal stress on it.
Less stress equals longer life.
Significantly longer, potentially. It slows down the natural degradation process of the insulation. Conversely, if you consistently run it hotter than its design temperature limit, even if it's within the insulation class capability, you will shorten its lifespan.
What about voltage? What if you need to run it at a voltage slightly different from its nameplate rating?
Alternators usually have a tolerance band, maybe plus or minus 8% around their design voltage. If you need to operate consistently outside that band,
Yeah.
you might need to degenerate it. That means reducing the kVA load you put on it.
To protect it?
Exactly. Operating too far off the design voltage can cause extra heating or other stresses, so de-rating compensates for that.
Okay, switching gears a bit, safety. Hugely important with electricity. What are the must-dos for PTO generators?
Non-negotiable. Safety first, always. Following the manufacturer's guidelines, like those from Mech Alte during installation, operation, and maintenance, is critical.
And grounding. I assume that's essential.
Absolutely fundamental. The generator frame must be properly grounded to prevent electric shock hazards.
Who's responsible for adding things like circuit breakers?
That falls on the installer. They need to ensure the whole setup includes necessary safety protections, circuit breakers for overcurrent, maybe specific overload protection, emergency stop buttons readily accessible, all the required guards and interlocks.
What about the physical connection, linking the generator to the tractor? Any safety points there?
Oh yes, the mechanical coupling is critical too. It has to be aligned correctly. Misalignment can cause severe vibration, which can damage the generator, the PTO shaft, or both, and that creates a safety risk.
And environment matters too, right? Like temperature.
Definitely. Most generators are rated for their full output under specific conditions, often something like a maximum ambient temperature of 40 degrees Celsius.
So about 104 Fahrenheit.
Right.
Yeah.
And usually below a certain altitude, maybe 1,000 meters, because the air is thinner, higher up, and cooling is less effective.
So if you're operating in hotter conditions or at high altitude, you might need to.
They rate again, reduce the expected output to keep things safe and prevent overheating.
What about routine maintenance? What does that typically involve?
It's usually fairly straightforward. Regularly check that all the bolts, especially mounting bolts and electrical connections, are tight. Vibration can loosen things over time.
Okay. And cleaning.
Keep the exterior clean. Compressed air is good for blowing dust off the vents and casing, but crucially, never use liquids to clean it, and don't blast compressed air directly onto internal electrical parts like the windings or the regulator.
You mentioned the regulator. What does that do?
The voltage regulator. Devices like Mech Alte's DER series are pretty sophisticated now. Their job is to automatically keep the output voltage stable, even if the electrical load changes suddenly, or the tractor engine speed varies a bit. Very important for protecting sensitive equipment.
We've mentioned Mech Alte a few times. Can you tell us a bit more about them? They seem like a key player.
They really are. Mechalti is a major global manufacturer of alternators. They're used in all sorts of generator sets, including these PTO units.
What are they known for?
They put a strong emphasis on quality, particularly their insulation systems. For example, they developed something called the HVI system, working with another company, Von Roll.
It's VA.
Yeah, it's designed for higher voltage generators, up to nearly 16 kV, but the technology often influences their lower voltage products too. It offers great thermal performance, handles voltage spikes well, and uses an environmentally friendlier epoxy resin. It's VOC-free.
Sounds a dance. Are they just based in one place?
Oh no, they're very international. They have significant operations in Italy, the UK, Spain, Germany, India, China, North America, a truly global footprint.
So good support worldwide, presumably.
That's the idea. And importantly, their products are designed to meet relevant standards, like the EEC directives in Europe, which means they meet strict safety requirements when used correctly.
Okay, so wrapping things up. It really seems like PTO generators are a genuinely practical, often cost-effective way to get power where you need it using machinery you might already own.
That's the essence of it, yes. We've sort of walked through why they exist, leveraging that tractor power and the basics of how they work, especially focusing on that crucial alternator component.
And understanding manufacturers like Mech-Alt helps see the technology behind it.
Exactly. Hopefully this gives you a solid foundation for understanding these useful machines.
And for anyone listening who wants to dig deeper, maybe look at specific models or applications, where should they go?
A great resource is the Aurora Generators website. That's www.auroragenerators.com. They have a lot of detailed information, specs, articles, really worth checking out if you're interested in PTO generators.
It's excellent. www.auroragenerators.com. We'll make sure that's clear for everyone.
And just a final thought to leave you with. Think about how powerful that concept is using existing machinery like a tractor to generate electricity. It really speaks to greater self-sufficiency, doesn't it? And resilience, whether you're on a farm, a remote work site, or just preparing for emergencies. It's about making the most of what you have.